Today is April 28th, 2026. Here's your space and science briefing. NASA's Artemis III crewed lunar landing slips to no earlier than late 2027 as planners refine the timeline. NASA has formally updated the target launch window for its first crewed lunar landing under the Artemis program. This adjustment gives engineers more time to complete vehicle testing and address integration challenges ahead of sending astronauts back to the moon's surface. The delay reflects the realities of complex spacecraft development where safety and reliability must come first. Vehicle integration has proven trickier than initial schedules anticipated, yet this mission remains the cornerstone for returning humans to the lunar surface. I appreciate how the agency is choosing a realistic pace rather than rushing forward. While we wait a little longer for boots back on the moon, new research is raising some very personal questions about what long-duration spaceflight might do to the next generation of explorers. Ongoing studies are examining how microgravity, fluid shifts, radiation, and other spaceflight stressors could affect reproductive processes. The work looks at everything from cellular changes to how the body manages hormones in weightlessness. These findings carry direct implications for future lunar bases and crewed trips to Mars. One day, humans might consider having children off Earth. Understanding these effects will be critical for making those deep space missions sustainable. It is a reminder that exploring the solar system touches on the most fundamental aspects of being human. Speaking of future human presence in space, one company is rapidly expanding its satellite fleet to bring broadband to every corner of the planet. A United Launch Alliance Atlas V rocket successfully delivered a record-tying heavy payload of 29 Project Kuiper internet satellites from Florida. The mission marks another step in building out Amazon's low Earth orbit constellation to provide global broadband coverage. This flight ties an existing payload record and shows the Atlas V still delivers impressive performance. Even as newer vehicles come online, the rocket continues to prove its heavy lift capability. Each successful launch brings the constellation closer to connecting remote communities worldwide. It is impressive to watch commercial space move at this pace. While Amazon builds its internet constellation, SpaceX continues pushing the frontier of full reusability with its most ambitious rocket yet. SpaceX has rolled out a next-generation Starship vehicle, booster, engines, launch pad, and test site. The program now marks 3 years since its first flight. Engineers are following a test-like-you-fly philosophy that treats every ground test as close to flight conditions as possible. The focus remains squarely on rapid reusability for deep space missions. Upgraded hardware across the stack suggests they are closing in on the reliability needed for regular operations. Watching this rapid iteration feels like witnessing a genuine engineering revolution in real time. Before we leave Earth orbit, a quiet but vital Russian cargo delivery just arrived at the International Space Station. The uncrewed Russian Progress 95 spacecraft successfully docked to the aft port of the Zvezda module. It launched 2 days earlier from Baikonur carrying food, fuel, and other essentials for the station crew. This resupply mission ensures continued smooth operations aboard the orbiting laboratory. Regular cargo runs like this keep the crew healthy and the experiments running without interruption. In the background of flashy new rockets, these routine flights are what make long-term human spaceflight possible. They remind us that living in space still depends on steady logistical support. While the station keeps humming along, NASA leadership is making strong statements about America's lunar timeline. The head of NASA expressed strong optimism that American efforts will land astronauts on the moon ahead of any competing lunar program. The comments come as the agency balances international partnerships with domestic workforce and funding priorities. This confidence reflects a clear focus on maintaining the United States' lead in crewed exploration. At the same time, lawmakers continue to scrutinize budgets and potential program changes. It is a delicate dance between ambition and practical realities. That confidence was on full display this week when NASA's administrator nominee spent 2 days testifying on Capitol Hill. The NASA administrator nominee appeared on Capitol Hill to discuss reduced funding proposals, workforce changes, and greater commercialization of space activities. Jared Isaacman defended the administration's vision for accelerated exploration. Lawmakers raised concerns about potential program cancellations during the hearings. The back and forth highlighted how policy decisions shape the pace of our return to the moon. It was interesting to see a nominee with deep private sector experience addressing these questions directly. These conversations will likely influence priorities for years to come. Now, here's something that blew my mind when I looked into it. A new theoretical model suggests energy from decaying dark matter could have altered early galaxies and accelerated the formation of supermassive black holes. If you compressed all the dark matter in a typical galaxy into a volume the size of our solar system, its total mass would still outweigh everything visible by a factor of 5. Streams of energetic particles would pour into the hearts of newborn galaxies, heating and compressing the gas clouds that would otherwise take far longer to collapse. Imagine riding alongside one of those decay products, racing at nearly the speed of light. Within a few 100 million years, it could dump enough energy to trigger runaway accretion onto the first generation of black holes, letting them balloon to millions of solar masses while the universe was still less than 1 billion years old. The mechanism relies on a specific decay timescale, roughly 10 to the 25 years for some proposed dark matter candidates. That neatly matches the window when the James Webb Space Telescope sees these unexpectedly massive objects already in place. Yet we still do not know the exact particle properties that would produce exactly the right amount of energy without erasing other cosmological signals we already trust. We can model the gravitational ripples it leaves behind, but nobody yet knows whether this exotic decay truly happened, or if we are still missing an even stranger piece of the puzzle. That same telescope is also showing us how difficult some observations still are, even with the most powerful instrument we have ever launched. Astronomers used the James Webb Space Telescope to study promising exomoon candidates around a star in the habitable zone they were hoping to find an Earth-Moon analog. The host star's activity overwhelmed the faint signals from potential moons. This illustrates the extreme challenges of directly detecting small bodies around distant worlds. Even cutting-edge instruments face limits when stellar noise drowns out the subtle clues we seek. It is a humbling reminder of how much ingenuity will still be needed to confirm the existence of exomoons. Closer to home, our Mars rovers continue to uncover surprising chemistry that could rewrite parts of the red planet's story. The Curiosity rover analyzed a Martian rock and identified 7 previously unseen organic molecules. This marks the most diverse collection detected so far in a single sample. Curiosity drilled into the rock inside Gale Crater, and its onboard laboratory detected these distinct organic molecules that had never been seen before on the red planet. The molecules survived billions of years of radiation and oxidation. This discovery adds to the growing inventory of complex carbon chemistry on the red planet. It informs our understanding of its past habitability and paints a richer picture of the complex chemistry that existed when water once flowed across the surface. Each new detection helps scientists reconstruct the environmental conditions that might once have supported prebiotic chemistry. The rover continues to climb through layered sediments that record millions of years of Martian history in one convenient outcrop. What would it mean for our search for ancient life if these organics turn out to have a non-biological origin we have not imagined yet? While Curiosity gives us new close-ups of Martian rocks, NASA's orbital eyes just captured a spectacular seasonal portrait right here on Earth. NASA's Earth Observatory released a striking satellite image showing vibrant red and orange beech forests across southern Patagonia. The view captures the southern hemisphere autumn at its peak. It highlights seasonal changes on our own planet while reminding us how orbital remote sensing reveals dynamic ecosystems. Seeing Earth from space like this puts our planetary home in beautiful perspective. The fiery colors look almost otherworldly, yet they belong entirely to the world beneath our feet. That same sense of wonder is alive and well among backyard astronomers who continue to produce stunning images with surprisingly modest gear. Enthusiasts posted detailed smartphone and digital single-lens reflex captures of the Orion Nebula and the Sombrero Galaxy. They used modest backyard telescopes and careful processing to create these images. The results demonstrate how accessible equipment combined with patience can still reveal the beauty of deep sky objects. It is genuinely inspiring to see what dedicated amateurs achieve from their own backyards. These images connect all of us to the cosmos without needing million-dollar observatories. Before we go, keep an eye on how the Artemis timeline adjustments and the ongoing congressional discussions might shape the next round of lunar mission contracts. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I'm Patrick in Vancouver. See you tomorrow. This podcast is curated by Patrick, but generated using AI voice synthesis of my voice using 11 Labs. The primary reason to do this is I unfortunately don't have the time to be consistent with generating all the content and wanted to focus on creating consistent and regular episodes for all the themes that I enjoy, and I hope others do as well.
drifting softly through the black. A million stars behind our back. The void hums low.